The more you refer back to the cheat sheet, then you'll say, okay, domain. When we're trying to find the domain or vertical asymptotes, where do we look? Denominator. If you're trying to find the x-intercepts or the zeros, where do you look? Look at your cheat sheet. Where do you look for x-intercepts or zeros? Numerator, okay? How do you find the y-intercepts? You plug in 0 for what? All the x. How do you find if there's a horizontal asymptote? You compare numerator degree to the denominator degree. Good. What about a slant asymptote? How do you find that? Long division. Good. And then holes. What's the process for holes? We're going to factor. Anything that is the same, you cross it off, set equal to 0. You get an x value, then you plug that back into the simplified one. So it's really not that, I promise. So here are the directions. Here are the directions on how to graph. This is really quite simple. The only thing that takes really a little bit of brain power is to figure out where your graph exists. And it's just because you're going to be plugging in and evaluating, but I'll show you that in a second. So let's just talk about this. You're going to have a question on your test, and it's going to be just like this, and it's going to say, go ahead and graph. And it's going to ask, I'll have a line so you don't have to guess for the vertical asymptote, horizontal asymptote, all that stuff. Please remember, you're allowed to use my color pencils, anything you need. But the graphing practice that is available to you to work on, Mrs. Thompson just worked it out with her class on a video. I'm going to send you guys the video, post it, whatever, so you guys have access to it. So just try to work on that this weekend. But if we're going to graph, we need to identify a bunch of stuff. Okay, so let's talk about the stuff we need to identify. The first thing we're going to talk about, let's find our domain. And what goes hand in hand with domain? Vertical asymptote. So, domain and vertical asymptote. Those things kind of go together. Where do we look? What do we do? We set the denominator equal to 0, right? Or not equal to. Kind of looking at it the same way. So what can x not be? 2. So that means your vertical asymptote is at x equals 2. What is my domain? Negative infinity to 2, and then 2 to infinity. So how do we graph our vertical asymptote? Well, where is x equals 2? And we're talking about a vertical line. So I go over to positive 2, and I'm going to draw a dashed line. How come I'm not drawing a solid line? Because it's not an actual line. It's just a boundary. That means my boomerangs are going to get real close to that, but not touch it. All right, so the next thing I want you guys to find, and again, I'll have this all listed out so you can see, is the horizontal asymptotes. How do we find the horizontal asymptotes? You compare what? Numerator degree to the denominator. So look at your function. What is the degree of the numerator? 1. What's the degree of the denominator? 1. What is the relationship between 1 and 1? Less than, greater than, or equal to? Equal to. So what is my asymptote if it's equal to? Leading coefficient of the numerator, which is what? 5, over the leading coefficient of the denominator, which is 1. So I'm going to go up here to where y is 5. 1, 2, 3, 4, 5. I'm going to do a little dash line. So you guys now kind of have your 4 quadrants. Do you see like a top left, bottom left, top right, bottom right? Your boomerangs are going to exist in 2 of those. We're going to figure out where they are in just 1 second. So let's do some other things that would help us graph. Let's find the x-intercepts, or the zeros. Look at your cheat sheet. How do you find the x-intercepts? Set what equal to 0? Numerator. So I say 5x equals 0. So x equals what? 0. So where is this graph going to cross the x-axis? At 0. Okay, so 0, 0. How do I know it's 0, 0? Well, if you find the y-intercept, what do we do to find the y-intercept? You plug in 0 for what? X. So I have 5 times 0 over 0 minus 2. What's 5 times 0? 0. What's 0 minus 2? Negative 2. What's 0 over negative 2? 0. So where is this graph going to cross? Right here. Is there a slant asymptote? I told you guys yesterday. How do you know if there's a slant asymptote? If there's a horizontal asymptote, is there a slant asymptote? No, you can't have both. So is there a horizontal asymptote here? Yes. So what's your answer for slant asymptote? None or no. And are there any holes? If you factor the top and the bottom, is there anything exactly the same on the top and the bottom? No. So are there any holes? None. All right, good. So now we're going to figure out where our boomerangs lie. And the best thing to do is you pick a point to the left of the vertical asymptote and to the right of the vertical asymptote. And you plug that value in for x. So let's pick a number. My vertical asymptote is what? 2? Yes or no? Okay, so pick any number to the left of 2. Any x value. -1? Okay, fine. So we're going to plug -1 into our function. I'm going to say, what is my y value when I plug in -1 for x? So 5 times -1 over -1 minus 2. Well, what's 5 times -1? -5. And then what's -1 minus 2? -3. So when I plug in -1 for x, I get out what? Positive 5/3. You guys agree? So where would that point be? About. You're not going to get anything perfect, but where would it be about? So -1 and here-ish. Now what you've just shown me, guys, because when you go to graph these, your boomerangs are either going to be above or below the horizontal asymptote. So look at where the intercept is and look at where that point is. Is it below the yellow line or is it above the yellow line? It's below it. So then this is all you have to do to draw your boomerang. Just draw some sort of a little shape here that goes through these points, that gets close to the asymptotes but doesn't touch it. That's all you have to do. You're figuring out where it exists. If you would have plugged in -1 and gotten like 15, so it's way up here, then your boomerang would have been up there. But all you have to do is just figure out where it lies in respects to the horizontal asymptote. If it was above it, you go above. If it's below, it's below. Where do you notice that the intercept was? Below or above it? Where was the x and y intercept? Below the horizontal asymptote or above it? Below it. So that was a hint of where your boomerang existed.
And so you do touch the x-intercept?
Yeah, it goes through the x-intercept. Just doesn't touch the asymptotes. All right, so now let's pick a point to the right of your vertical asymptote. Any number. Some of you want to pick 3, some of you want to pick 10. It doesn't matter. Just pick something bigger than 2. So what are we going to say? Okay, let's try 3. So x equals 3. We're going to evaluate. So 5 times 3 over 3 minus 2. What's 5 times 3? 15 over 1. So if I go over to 3, where is 15? Is it below the horizontal asymptote or above it? It's like way up here, right? So all you need to do is say, oh, okay, then my boomerang is going to be up here. It's going to get close to the asymptotes, but not touch it. You do not have to be precise. I don't need you to find 15 points and make it perfect. But you should not ever cross the vertical asymptote. All right, get really close to it. Don't touch it. Sometimes they cross horizontal, sometimes they don't, but just drawing it in a general direction is fine. But generally, that's the hardest part of graphing this, is just finding additional points, like plugging in, because you have to evaluate with fractions. All right, let's do the next one. Next, a bit different. I did all 3 of these because they're a little different. All right, let's go through the list. First of all, we're going to find domain, which also goes with our vertical asymptote. So where do I look for domain and vertical asymptote? Denominator. So we're going to say x squared minus 25 equals 0. Guys, what's my answer to this? What kind of 5? Plus or minus. So how many vertical asymptotes do I have? Now I have 2. I have x equals positive 5 and x equals negative 5. If you want to put plus or minus, that's fine. Just make sure you have 2.
Difference between
Equal
equal to 0 and not?
to 0 is telling you where your vertical asymptotes are. When you find the domain, you set it not equal to 0, you're figuring out what those values are that would make your denominator 0. So your vertical asymptote, your domain, I mean, it doesn't really matter because you're writing your domain. How would you write this? You can use any numbers but what? So it'd be negative infinity to negative 5, negative 5 to 5, and then 5 to infinity. Your vertical asymptotes are where the graph becomes undefined. So when you're working it out, if you put equal to or not equal to, it doesn't really matter. Just as long as you understand the concept of the vertical asymptotes are like where you have to have your domain restrictions, where it like stops and starts. So guys, if you're going to draw these vertical asymptotes, you have two. 1, 2, 3, 4, 5. One here. 1, 2, 3, 4, 5. And one here. So this graph is going to look a tad bit different, but we're going to do the exact same thing that we did before. We found our vertical asymptotes. We found our domain. Let's find our horizontal asymptotes. How do we find horizontal asymptotes? Compare what? Numerator to denominator. What's the degree of the numerator? 2. Highest exponent, guys. That's what we're looking at. What's the degree of the denominator? 2. So 2 is what to 2? Equal to. So what's your horizontal asymptote? Y equals 2 over 1, so 2. So right at y equals 2, go ahead and draw a dotted line. If I have a horizontal asymptote, what do I know about my slant asymptote? Is there one? No. None. Good. Let's talk about holes. If you factor the numerator, it's 2x squared. If you factor the denominator, it's x plus 5, x minus 5. Is anything exactly the same on top and bottom that's going to cancel out? No. So do you have any holes? No. Tell me how to find my x-intercept. Numerator equal to 0, okay? 2x squared equals 0. So what's x equal? 0, all right? How do we find the y-intercept? Turn all the x's to 0. Well, what's going to happen? It's going to be 0. So your graph is going to cross right there. Now, when you have, do you guys see how we have two asymptotes? So now we have 3 vertical sections. We just have like left and right hand side. We have 3 sections. We have to check all of the sections to figure out where your graph exists. On the outsides, you're going to have some sort of a boomerang. It's either going to be a boomerang on the top or a boomerang on the bottom. On the inside, you're either going to have like a snaky thing, a cubic, or a parabola. So that's what we have to check on the inside and the outside. So let's start with a number that's less than negative 5, to the left of the vertical asymptote. What would you want to pick? Negative 6, okay? So I'm going to say x equals negative 6. I'm going to plug it into this equation. So I have 2 times negative 6 squared over negative 6 squared minus 25. Okay, so what's negative 6 squared? 36 times 2 is 72. Over. What's negative 6 squared? 36 minus 25. 11. All right, so when you plug in negative 6, you get 72 over 11. I don't need to know exactly where that is, but how many times can 11 go into 72 without going over? 6-ish, right? 6 and a bit. So if you were going to plot that point, you'd go over negative 6. Where is 6-ish? Is it above or below that horizontal asymptote? It's above it, right? It's up here somewhere. So you know your boomerang's going to be up here. If you got your answer to be like negative 4, then it would be below, and you would just draw it below. Easiest thing to do is just plug in a number and then figure out if it's above or below the horizontal asymptote. Let's do the same thing on the other side, the other outside. Let's pick a number.
If it was below, it would turn the other way, right?
It'd go like this if it was below. Let's pick a number to the right of the furthest vertical asymptote. Can we use 6? What's going to happen when we plug in 6, guys? Yeah, when I plug in x equals positive 6, well, what happens when you square a number? It becomes positive. So the same thing's going to happen, right? Your same result. When you plug in positive 6, you'll get, again, 72 over 11. So where is that? Is it above or below the horizontal asymptote? It's above, so it's going to be over here. Now here's where we have to do a little bit more thinking. Because you need to see the shape. You need to pick something that's to the left of that intercept and to the right of the intercept. Because you need to see if it's going to make like a snaky looking thing or if it's going to make a parabola. When you have 3 sections, 2 asymptotes, that's what it's going to look like, one or the other. So let's pick something to the left of 0. -1, okay? So when I plug in x equals -1, well, I have 2 times -1 squared over -1 squared minus 25. What's 2 times -1 squared? 2. And then what's 1 minus 25? -24, so that gives me -1/12. Okay, so think about this, guys. Where is -1/12? Is it above the x-axis or below it? It's a little bit below, okay? So now let's pick a number to the right of that intercept. What do you want to pick? Pick a number to the right of 0.
If we said 1, would it be the same?
If you plug in 1, what's going to happen? You're going to get the same thing, so your point's going to be here. So what kind of a shape is going to be made in the middle? Is it going to be like a snaky thing, or is it a downward parabola? It's a downward parabola. It's going to go like this. You have to have the general shape and in the right area. Sometimes when you pick something to the left, it could be below the x-axis. Then when you pick something to the right, it's above, so it makes like a snake. Sometimes on the left, it could be above, and on the right, it's below, so it makes a snake this way. You just have to check either side just to make sure you understand the shape. But that's all we're looking for when you're graphing. It does not have to be that the points are exact and you know exactly where 72 over 11, that's not it. You guys aren't using a graphing calculator, so you just need kind of the general shape. All right, let's do the last one. I made this one up just a little bit ago, so if you want to take a picture of it or whatever, go ahead. Let's go through the mechanics. What's the first 2 things that I have been finding every single time? Vertical asymptote and what? Domain, because those things go hand in hand. Where do we look for the vertical asymptote and the domain? Denominator. So x plus 1 equals 0. So what's x equal? -1. So my vertical asymptote is that x equals -1. That means my domain is what? X plus 1, negative infinity to -1, union, -1 to what? Infinity. Perfect. So I'm going to go to my graph. I'm going to draw a vertical dashed line right here at -1. All right, then the next thing we've been finding is our horizontal asymptote. Compare the degrees of the numerator. Numerator degree to denominator degree. What's the degree of the numerator? 2. What's the degree of the denominator? 1. 2 is what then 1? Greater than, okay? When your numerator degree is greater than the denominator, what is your horizontal asymptote? Look at your cheat sheet. What is it? It's none. Well, wait a second. If I don't have a horizontal, what does that mean I do have? It does mean I have a slant, so let's go ahead and find that. I don't have a horizontal, that means I have a slant asymptote. Guys, how do we find a slant asymptote? Long division. So what goes on the outside? My x plus 1. What goes on the inside? My negative 3x squared plus 2. So what do I need to have? What do I need to have, guys? I have to have a 0x. It can be plus or minus, whatever you guys want to do. It doesn't matter. Just got to have that placeholder. So we're going to go first term into first term. X times what gives me negative 3x squared? Negative what? 3x. Okay, go ahead and put it above your 0x. Get your subtraction ready. So now we're going to multiply. Negative 3x times x is negative 3x squared. Negative 3x times 1 is minus 3x, correct? Before we subtract, what do? Change, change, change. So 0x and 3x is positive 3x. My x squareds cancel, and I bring down my plus 2, right? So first term into first term. X times what gives me 3x? What kind of 3? Plus 3, okay. Do I have to do anything else? No. So your answer for slant asymptote, you guys would say my slant asymptote is y equals what? Negative 3x plus 3. You have to have it in y equals mx plus b, slope intercept. So now we're going to graph that line, guys. That's your other asymptote. If you don't have a horizontal, then you're going to have one of these slant ones. So where is my intercept? Positive 3, and what's my slope? What's my slope? Negative 3 over 1. So I go down 3, 1, 2, 3, and over 1. Down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. So then I have a slanted line like this. So now we'll figure out where our boomerangs are. Well, let's find intercepts. How do you find x-intercept? X-intercept. What do we do? Numerator equal to 0. So negative 3x squared plus 2 equals 0. So negative 3x squared equals negative 2. Yeah? Divide by negative 3. X squared equals 2/3. So then I have to do what? Take the square root. So I get x equals plus or minus the square root of 2/3. Now, guys, I know that you're like, we can't have radical denominator. The square root of 2/3, is that a huge number or is it teeny tiny? It's small, right? So this graph is going to cross the x-axis like here-ish. You need the general area. Plus and minus square root of 2 over 3. It's tiny, tiny, tiny. But you have to understand the general area. So where does your boomerang exist here? Do you see in between the blue line and the yellow line? That's where your boomerang is. It's just stuck in here. That's not a good color. Go back. Yellow. It's smushed in here. It's not going to cross your vertical. It's not going to cross. That's just your guidelines. If your intercepts are right there, then that's where your little boomerang is going to exist. And again, more graphing practice. We're going to have a video on it. I'm going to send you guys home with it. This is not a major portion of the test, I promise, because this is hard to do by hand. We just mechanically, we want you guys to understand the mechanics on how to find the domain, how to find horizontal asymptotes, that sort of thing. The graphing part is not the biggest deal. So now let's pick a number over here to the left of your vertical asymptote. We already know where it lies on the right of the vertical asymptote. Let's pick a number to the left. Any number you want. Negative 2? All right, so negative 3 times negative 2 squared plus 2 over negative 2 plus 1. What's negative 2 squared? 4, and 4 times negative 3? Negative 12 plus 2? Negative 10. Over negative 1, so 10. So I plug in negative 2, and I get something way up here, yeah? So that just means your boomerang is up here. That's it. It's not over here, in this section here. It's above, up there. That's all you guys need to do is just get the general direction. Probably won't have a slant that you have to graph on your test. It's going to be very basic, but I want you guys to understand what a slant would look like. It has a vertical asymptote and then a slanted line. So then your boomerangs just exist in like different areas. It's not just in quadrants. They're kind of smooshed together.